Welcome to part one of 5 Steps to Regenerative Climate Resilience, an introduction for technical service providers. This presentation is the first in a two-part series introducing a new web-based climate resilience planning resource hosted by the Glynwood Center for Regional Food and Farming, based in Cold Spring, New York. This resource was designed and constructed by Glynwood's Resilient Agriculture team to support regenerative climate risk management and resilience planning by farmers managing small-scale, diversified crop and pasture-based livestock operations in the Hudson Valley. The first video in this series briefly presents the principles and practices of agricultural adaptation to climate change, introduces the risk management benefits of integrating resilient science into farm management, and explains how social-ecological resilience concepts are used in Glynwood's 5 Steps planning process. The second video in this series introduces each step in the 5 Steps planning process, offers some tips for how technical assistance providers can use the new resource in their work with producers, and previews a new climate resilience planning resource scheduled for release next year by the USDA-Sustainable Agriculture Research and Education Program. My name is Laura Linick. I'm an award-winning soil scientist and agronomist with broad experience in soil health and sustainable cropping systems research, education, and policymaking. Over the last decade, I have led federal and state agricultural adaptation and resilience planning, developed and delivered climate resilience workshops to farmers and technical assistance professionals throughout the U.S., conducted research in agricultural resilience policy and practice, and worked with private business to create carbon management plans and conduct resilience assessments of operations and strategic plans. I am the author of Resilient Agriculture and host Real World Resilience, a digital collection of whole farm adaptation, climate risk, and resilience stories gathered from farmers and ranchers growing food across the U.S. I led the design and development of the 5 Steps resource while serving as Glynwood's Director of Agriculture in 2023. This resource draws on more than a decade of my own work to understand what we can do to reduce the vulnerability of agriculture to the changing weather patterns associated with climate change. You can learn more about me and my work at cultivatingresilience.com. Glynwood's Resilience Planning Resource can be accessed online at regenerativefarmresilienceguide.org. Access to all of the resources on the website is free of charge and does not require user registration or the sharing of any user information. Key resources on the website include a planning guide for farmers that can be downloaded as a PDF and a curated library of resilience planning resources that can be filtered by planning step. You can learn more about these resources and how farmers use them to create a climate resilience plan in part 2 of this video series. The principles and practices used in Glynwood's Resilience Planning Resource are based on USDA best practices in agricultural climate change adaptation as presented in the 2017 Bulletin, Adaptation Resources for Agriculture. This bulletin provides an excellent introduction to climate adaptation principles and practices with examples from commodity crop operations in the Midwest and Northeast. It recommends the use of adaptive management to address the unique risks to agriculture associated with climate change, and presents an adaptation planning workbook and an extensive menu of natural resource management strategies and associated practices useful to climate change adaptation. The principles of adaptation encourage farmers and ranchers to use adaptive management, to prioritize reducing climate risk to critical assets and most vulnerable assets, and to choose adaptation options that are most likely to be effective. When possible, include in these criteria for decision no regrets options and options with mitigation co-benefits. Notice that I've included a link to this bulletin below the image of the cover. Throughout this video series, you will see links to specific documents below the document image. I've also included links at the bottom of some slides to selected examples of research-based resources that support this presentation of the principles and practices of regenerative climate resilience planning. USDA recommends using an adaptive management framework to guide agricultural adaptation efforts. Adaptive management was developed to improve the management of complex adaptive systems like natural and working lands through the formal observation of system response to management intervention. Adaptive management is particularly useful when managing complex adaptive systems in highly variable and rapidly changing conditions. Adaptive management involves moving through a series of planning steps designed to clarify management goals and resources, identify challenges and opportunities to these goals, make a plan, put it into action, and observe how the system behaves in order to improve the manager's ability to achieve business and family goals over time. In climate change adaptation, these steps include assessing the vulnerability of a farm operation to climate change effects, identifying and implementing adaptation options, and observing how the implemented options affect farm performance. Adaptive management has long been used by natural resource managers, agricultural technical assistance providers, and some farmers in the U.S. I'd like to share just a few examples. The NRCS conservation planning process uses an adaptive management framework that breaks the customary 5 steps in adaptive planning into 9 planning phases. Whole farm planning is another adaptive management framework that has been developed for different purposes in U.S. agriculture. I've included here just a few examples of the different kinds of whole farm management resources that have been developed by technical assistance providers since the early 1990s. And finally, holistic management is a particularly well-developed form of adaptive whole farm management that uses a diverse toolbox of practices designed to help producers keep in mind the benefits of management strategies that cultivate the health and well-being of the people, the land, and the communities that their operations depend on to sustain performance over time. Holistic management is particularly useful to climate resilience planning because it includes some unique principles and practices that can help agricultural managers clarify and support family values, achieve business goals within available resources, and put a priority on natural resource and community health and well-being, both now and into the future. One of the major challenges of adaptation planning is translating science-based adaptation concepts into tangible on-farm actions and specific practices. Adaptation guidance also varies in specificity from general concepts to specific actions. This can make it difficult for farmers to identify appropriate actions that they can take to reduce climate risk to their operations. USDA recommends the use of an adaptation menu to help farmers move from broad adaptation strategies to specific adaptation actions, as shown here. Strategies can be broadly applied across a number of landscapes and farming system types. Approaches are more specific. Approaches describe how strategies can be employed in different types of agricultural systems and to meet different landowner goals. Tactics provide specific direction about what actions will be effective in a particular farming system, taking into consideration factors like site conditions, landowner goals, production system, markets, and business position. Keeping broad adaptation strategies and approaches in mind while identifying best fit tactics can help farmers clarify management intentions, consider a broader selection of adaptation options that can support their business goals, and select more effective actions to reduce climate risk to their operations. This bulletin shown here, Climate Change and Agriculture in the United States, Effects and Adaptation, was the first USDA publication to specifically address agricultural adaptation to climate change. I served as a member of the leadership team responsible for the development and production of this report as a contribution to the third National Climate Assessment. I also led the development of the chapter on climate change adaptation. We recognized then that climate change effects on weather patterns were already beginning to change the agricultural risk management landscape in ways that presented novel and unprecedented challenges to agricultural sustainability. A key driver of this change was a new kind of risk called climate risk. Climate risk is the increased risk created by more variable weather and more frequent and intense weather extremes associated with climate change. Climate risk changes the agricultural risk landscape because it tends to increase the probability of a damaging event as well as the consequences of that event, as shown here. Because I served as the lead author on the adaptation chapter, I was tasked with reviewing research-based knowledge to help us understand the behavior of agroecosystems in highly variable conditions and what we knew about how to design and manage these systems to reduce the risk of disruption and damage caused by changing weather patterns. As a result of this work, we highlighted the value of applying resilient science to develop new risk management practices better suited to managing climate risk in agriculture. The concept of resilience has origins in a diverse set of disciplines. For example, as shown here, engineering, psychology, disaster management, and ecology. We concluded that the kind of resilient science developed by ecologists that study human-dominated ecosystems, called social-ecological resilience, is best suited to addressing the challenges of climate risk in U.S. agriculture. This is because social-ecological resilience science has a long history of development and application in the adaptive management of natural resources. More recently, this type of resilient science has been applied to climate change, vulnerability, and adaptation in many types of human-dominated systems. For example, neighborhoods, cities, and regional landscapes, as well as in agriculture and food. Social-ecological resilience science offers us new concepts, a new language, and new frameworks to understand and cultivate the qualities and behaviors that are most likely to sustain the health and well-being of agroecosystems under conditions of high uncertainty. So what is resilience? The Resilience Alliance curates a diverse international collaboration of basic and applied scientists who work to develop social-ecological science. The organization's website is an excellent source of research-based resources about social-ecological resilience principles and practices. The Resilience Alliance defines resilience as the capacity of a social-ecological system to maintain its essential structure and function as conditions change, and recognizes three behaviors that are key to this capacity: the ability to self-organize, to learn, and to adapt. These are just a few of the qualities and behaviors of resilient agroecosystems that have been explored by social-ecological resilience scientists and practitioners. We designed the 5 Steps planning resource to invite producers to consider adaptation options that promote these qualities and behaviors, with planning tools that encourage the selection of a mix of adaptation options that cultivate all 3 resilience capacities, as shown here: response, recovery, and transformation. Practices that contribute to the health and well-being of the whole farm and recognize the role of the surrounding community in farm success. support the accumulation of a diversified portfolio of assets under management, and promote healthy relationships, regional self-reliance, and the accumulation of community-based wealth, including healthy natural, human, and social resources, plus locally controlled financial and technological resources. We integrated one additional resilience concept that promotes resilience to both expected and unexpected events while reinforcing climate adaptation principles, targeted versus general response strategies. Recall that climate change adaptation principles involve addressing specific risks to critical assets, along with more general risks, and to select no-regret strategies that offer climate change mitigation benefits when possible. Thinking about adaptation strategies as a targeted versus a general response is a practical way for producers to easily integrate adaptation principles and resilience science into operations planning. Notice that targeted response strategies tend to reduce the risk of specific threats, for example, dry periods and droughts, a specific weed, pest, or disease, or a specific environmental condition like heat or poor air quality, as shown here. Because targeted response strategies do not typically offer significant co-benefits beyond reducing the targeted threat, there are few no-regrets options among this type of strategy, and the return on investment in these strategies will be low if a specific threat does not occur in a particular year. Some targeted response strategies offer climate change mitigation benefits, primarily through emissions reductions. In contrast, general response strategies offer multiple benefits to the farm. For example, investments in soil health, crop diversification, or employee development, as shown here. Many general response strategies are also no-regret strategies because the multiple benefits associated with these strategies assure a high return on investment regardless of the specific threats that occur in any particular year. Many general response strategies also offer climate change mitigation benefits. Social-ecological resilience theory suggests that it is both more expensive and more risky to depend only on targeted risk management strategies, which are currently the norm in traditional agriculture risk management. This is because as weather-related disruptions to agricultural operations grow more variable and intense, targeted strategies grow more expensive, more difficult to manage, and will ultimately fail. In addition, investing in targeted strategies can actually reduce the resilience of the agroecosystem to a disturbance or shock that is less likely or completely unexpected. Another way to think of this is that targeted response strategies tend to increase the fragility of the farm system as a whole. In contrast, general response strategies tend to increase agroecosystem resilience by reducing the risk of damage associated with both expected and unexpected disturbances and shocks. As an additional benefit, general response strategies tend to offer broad co-benefits both on and off the farm. For example, the benefits of healthy soils to the regulation of water quality and quantity both on the farm and in communities downstream. The most effective climate risk management plans will use a mix of both strategies. After completing work on the USDA Bulletin, I was interested to learn more about how farmers and ranchers might be using resilience thinking in the management of their operations. So I began a research project that has now spanned more than a decade and includes case studies of 45 award-winning diversified farmers and ranchers producing vegetables, fruits, grains, and livestock products across the U.S. Although these producers manage agricultural operations that range in scale from 2 to 185,000 acres, most are farming at or above the average scale for their type of operation in their location. Some are new to agriculture, others have been producing food for market for decades, and some have a way of knowing the land that stretch back 4 or 5 generations. They call the way they manage their businesses by many names: conservation agriculture, diversified agriculture, sustainable, organic, biodynamic, and regenerative agriculture, and more recently, climate smart agriculture. Despite the many differences among them, this group of farmers and ranchers are united in one purpose. They all seek to grow food that promotes healthy land, people, and communities. Here are some of the climate risk management strategies commonly used by the farmers and ranchers who participated in my project. These findings are consistent with other research conducted over the last decade to document the adaptation strategies of producers using a diversity of production philosophies to manage a diversity of agroecosystem types. Many of these climate risk management strategies are widely recognized today, but I want to point out some of the less common strategies that emerged in my own work with this group of award-winning diversified farmers and ranchers. Notice the last 4 strategies included in this list: diverse high-value markets, recovery reserves, engaged community, and personal resilience draw on a diversity of assets under management. All 4 of these behaviors are well aligned with social-ecological behaviors that promote the resilience of agroecosystems. We included whole farm adaptation and resilience stories from my work, as well as other sources, in the 5 Steps resource because we recognize the important role of storytelling in agricultural innovation. In addition, there is a rich and growing body of evidence in the importance of storytelling to inspire taking action on climate change. I collaborated with the SARE Communications Program to develop a bulletin designed to introduce climate risk to farmers and ranchers and encourage them to integrate resilience thinking into the design and management of their operations. We did this by explaining the factors that influence climate risk. Exposure describes local weather patterns and events. Sensitivity describes how weather events affect individual elements of the farm. For example, a specific crop, livestock type, soil type, or farm infrastructure. And adaptive capacity describes the resilience of the whole farm. We also explain the 3 types of resilience that are contributing to adaptive capacity. This is response, recovery, and transformation that together promote the resilience or adaptive capacity of the whole farm. And finally, we laid out the benefits to farm management of access to a climate resilience toolbox that includes adaptive whole farm planning and access to a diversified portfolio of assets under management. This SARE bulletin served as a core resource during the development of Glynwood's 5 Steps Planning Guide. I want to conclude this presentation by highlighting how the integration of social-ecological resilience science changes the USDA's recommended adaptation process. As shown in this table, Glynwood's 5 Steps resource promotes a whole farm planning framework that encourages farmers to include family and community well-being considerations in their adaptation planning. It encourages users to draw on the full range of assets under management, not just natural resources, and to include a mix of targeted and general resilience strategies that cultivate all 3 kinds of resilience: response, recovery, and transformation. Glynwood's 5 Steps process offers resources specific to the target audience, small-scale diversified operations producing vegetables and pasture-based livestock products for regional markets. Congratulations! We've come to the end of this presentation. I've collected here some of the resources that I've found most helpful in my own work to develop new agricultural planning tools to manage climate risk and cultivate the climate resilience of agricultural operations. Nearly all of them are available free online. I invite you to check them out if you want to learn more about the concepts and resources that I've highlighted in this presentation. If you have any questions, comments, or thoughts about the concepts and materials recommended in this presentation, or would like to discuss how you can tailor the 5 steps process to support the agricultural communities that you serve, please don't hesitate to reach out. You can reach me at cultivatingresilience.com or the Glynwood Center at info@glynwood.org. Remember that you can view the second video in this series to learn more about each step in the 5 steps planning process, some tips for how technical assistance providers can use the resource in their work with producers, and a new climate resilience planning resource scheduled for release next year by the USDA Sustainable Agriculture Research and Education Program.